Hello everyone, welcome to our daily physics problems, day 2. So today we have 7 identical light iron sticks that are connected to each other head to tail to form bridge across two planes, as picture shown. Point A is locked on a horizontal plane and point E can slide on another horizontal plane in the positive and negative x direction. Ignore the weight of the sticks. If we exert a force N downward on the point C, what is the tension or pressure on each of the iron sticks? So why don't you pause the video, uh, try to solve it on your own, and then come back to later and see how I did it. So in order to approach the problem, we need to define our system as a whole bridge. Then we balance the force. So first in the horizontal direction, we have F2 equal to 0 because the only force component have equilibrium. In the vertical direction, we have F1 is equal to N minus F3. And in the torque, if we define A as the pivot point, because let's define the length of the stick as L, and NL will be equal to N3 times 2L. And we have our system equation here. Let's try to solve it. So first we have F1 is equal to N minus F3. Let's find F3. F3 is equal to NL over 2L, which is equal to N over 2. Then we plug it back in. F1 is equal to N minus F2. N divided by 2, which is N over 2. After we have N1 and F3, we can start to think about the tension in the sticks now. Let's first define an isolated system that only consider the equilibrium of force at point A. And we assume that all tension are pulling force. And here we have 4 forces. In the horizontal direction, we have F2 plus T2 plus T1 times cosine of theta is equal to 0. Let's define that theta, that's horizontal direction. Then in the vertical direction, we have 2 forces. F1 plus T1 times sine of theta is equal to 0. Then we try to solve it. From the last vertical equation, we can know that T1 is equal to negative F1 divided by sine theta. And we know F1 already, it's n over 2. And sine of theta, the theta is actually equal to 60 degrees because we have 3 identical sticks conforming a triangle. So it has to be 60 degrees. And we solve it, we got n1 equal to negative n over the square root of 3. Then we plug it back into the horizontal equation that we listed out because f2 is 0, so we just forget about it. T2 minus n over square root of 3 times cosine of 60 degrees equals to 0. And T2 will be n divided by square root of 3 times 2. Then T2 will be equal to n divided by 2 times square root of 3. And now we need our second isolated system. Let's consider B. B have 3 forces there, T1, T3, and T4. Let's balance the force. So in the horizontal direction, we have, we have T1, T4 plus T3 times cosine theta equal to minus T2 times cosine theta is equal to 0. In the vertical direction, we only have 2 forces. So we have the T1 and T3, which T1 times the sine of theta is equal to plus the T3 times sine of theta equal to 0. Then from the last equation, we can already see that T1 is equal to negative T3. We already know T1, which is n over the square root of 3. So we can derive out that T3 will be equal to n over the square root of 3. So now let's plug it back into the horizontal equation we list out. The T4 will be equal to T1 cosine theta minus T3 cosine theta. We plug in T1 and T3, the value we just figured out. We got negative T4 is equal to n over the square root of 3. So n4 equal to negative n over the square root of 3. So now we know T1, T2, T3, and T4. T1 is negative n over the square root of 3. T2 is n over the 2 times the square root of 3. T3 is n over the square root of 3, and T4 is negative n over the square root of 3. 3 to go, we already solved 4. But actually we don't have to, because T1 and T6 are identical. They are in a symmetry. So by figuring out the symmetry, we know T6 equal to T1, T3 is T5 equal to T3. That's a typo. T3 is and T2 are the same. T7 and T2 should be the same. That was a mistake. Never mind. So in here, we got our final solution here. But why does some or part of them are plus positive, but some part of them are negative. It's because we assume all the forces are pulling. If they are positive, they're pulling. Negative, they are pressure. So that's for today.